This is a problem from your lab assignment from section 5.3. It says here to use part 1 of the fundamental theorem of calculus to find the derivative of a function g of x. This is a function defined by an integral. As g of x is equal to the integral from 1 to x of a function 4 divided by 3 or x to the third plus 2. And we're integrating with respect to t. Now when we integrate with respect to t, we look for the t variables in the integrand and then find the antiderivative or whatever, and then we evaluate it from 0 or from 1 to x. So the t variables will disappear, and then the x variable is on the top limit of the integral, and your function will end up being just a function of x. Okay, according to the fundamental theorem of calculus, if you have a g of x is equal to this integral, then the derivative of g of x is equal to that original function evaluated at x. So what they're saying is that g prime of x is equal to little f evaluated at x. So g prime of x is equal to little f evaluated at x. It's going to have to be this option. So part 2 is identifying your f of t inside of the integrand. So the f of t is equal to 4 divided by t cubed plus 2. So if it's 4 divided by t cubed plus 2, and we know that your derivative is just going to be f of x, we're literally going to copy this equation down, except we're going to, instead of x or instead of t, we're going to put x in. And so our final answer should be 4 divided by x cubed plus 2. So that's all there is to it with the fundamental theorem of calculus.